Section 4.6, Exponential and Logarithmic Equations. In this section, we'll solve exponential equations with bases that are like and unlike. So this is equations. We'll solve log equations, and we'll solve applied problems involving both exponential and log equations. First, we'll start with solving exponential equations with the same base. So if we have an exponential equation where the bases are the same, to solve, all we have to do is set the exponents equal to each other. So if 2 to this power equals 2 to that power, then the powers must be equal. So that tells us that to solve this equation, all we have to do is say x plus 3 is equal to 2x plus 5, and then we'll go ahead and solve. We'll subtract x from each side, which will give us x plus 5 is equal to 3, and then we'll subtract 5 from each side, giving a solution of x is equal to -2. Here again, we have an equation where the bases are the same, so all we have to do is set the exponents equal to each other and solve. 2x is equal to 3x minus 2. We can subtract 3x from each side, and then multiply each side by -1 and solve. So when the bases are the same, it's really easy. Here, why don't you go ahead and try this one. Solve 5 to the x plus 4 is equal to 5 to the 2x minus 8. So what if the bases aren't the same? Well, sometimes you can make them the same. For example, solve 2 to the 3x plus 2 equals 8 to the x minus 5. Now we notice that the bases are not the same, but 8 is the same as 2 cubed. So we have 2 to the 3x plus 2 is equal to 2 cubed to the x minus 5. And we know how to deal with exponents being raised to a power. We would multiply those together. So that tells us that 2 to the 3x plus 2 is equal to 2 to the, if we want to raise a power to a power, we multiply the exponents together. So now we have the bases are the same. That means we can set the exponents equal to each other and solve. So we would have 3x plus 2 is equal to 3 to the times x minus 5. Now, looking ahead, I think this equation's not going to have any solutions. Let's take a look. Yeah, if we subtract 3x from both sides, that tells us that 2 is equal to 5x, so this equation has no solution. There is no value of x that would satisfy that equation. So let's try another one. 16 to the 3x is equal to 64 to the x plus 3. So our goal is to try to write these using the same base. Notice that those are both powers of 4. 16 is the same as 4 squared, and 64 is the same as 4 cubed. So now we have an equation with an exponential equation where the bases are the same. Now, we know what to do when we're raising a power to a power. We multiply those numbers together. So we have 4 to the 2 times 3x would be equal to 4 to the 3 times x plus 3. Now that the bases are the same, we can say that these exponents should be equal to each other. So 2 times 3x is equal to 3 times x plus 3. And then we would just go ahead and solve. 6x is equal to 3x plus 9, subtracting 3x from each side, and dividing by 3, we have x is equal to 3. A couple more examples, just to use exponents that we are maybe more hesitant with. Here we have 5 to the 2x is equal to the square root of 5. And we'd like to write these as having the same base. So we have 5 to the 2x. But remember, the square root of 5 can be written as 5 to the 1/2 power. So we have 5 to the 2x is equal to 5 to the 1/2. In other words, 2x is equal to 1/2 dividing both sides by 2, or multiplying both sides by 1/2, we find out that x would be equal to 1/4. Okay, and one more. Here we have 1/3, and here we have 27. So let's make those both powers of 3. So 1/3 would be the same as 3 to the negative 1. And 27 would be the same as 3 cubed. And again, we'll do the same thing. We'll be multiplying these exponents together. So we have 3 to the negative 1 times x plus 4 is equal to 3 to the 3 times x minus 2. Now that we have the bases the same, we can equate the exponents. Negative 1 times x plus 4 is equal to 3 times x minus 2. And now we have a very simple equation that we can solve. So let's go ahead and do that together. Negative x minus 4 is equal to 3x minus 6. We'll add x to each side. We will add 6 to each side. And dividing by 4 gives us x is equal to 1/2. So here's one for you to try. And I think it's pretty easy to see that your first step is going to be to write 16 as 2 to the 4th power. And then do it the same way that we've done the other examples.